Good evening, children.
Good evening, ma'am.
Good evening, Miss.
Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Thank you for your patience. Good evening. Yeah, let's jump straight into the answers to these questions, children. I'm sure you have them ready. Yeah, answer the
Yes,
first one. Yeah, good. Pi is an integer, a rational number, an irrational number, none of these. Which is the right option?
Irrational number.
Yeah, because
Irrational, ma'am.
correct. Because
Irrational
pi
number.
has a non-terminating, non-repeating decimal expansion. Because pi, the value of pi is a non-terminating, non-repeating decimal. Somebody's mic is enabled. I think Hari Darshan, kindly disable your mic. Thank you. So the correct option is C. Pi is an irrational number. Next one. The product of any two irrational numbers is. Okay, the first option says always an irrational number. Now take this example, 3√7. It's irrational. Root 7, irrational. Now the product of 3√7 and root 7. All right, see the question here is the product of any two irrational numbers is. So 3√7 is irrational. Root 7 is also irrational. Now we see that the product of any two irrational numbers in this case is rational because root 7 into root 7 is 7 and 7 threes are 21, which is rational. Now, if you take this example, say 2√3 into root 2, the product of two irrationals, 2√3 is irrational, root 2 is irrational. The product of these two irrationals is 2√6, which is again irrational. Right? So which will be the correct option? See, we have taken two examples. Here, where both are irrational. And we see that the product of these two irrationals is rational. Here we have taken, again, two irrationals. The product of these two irrationals is irrational. So now read the options. The product of any two irrational numbers is always an irrational number, always an integer, may or may not be irrational, may or may not be irrational, never an irrational number.
May or may not be irrational, ma'am.
Correct. Option C, may or may not be irrational. Because you see here, in the first example we have taken, the product of two irrationals is rational. In the second example we have taken, the product of two irrationals is also irrational. So the product of any two irrational numbers is, we'll take out this is from here, the product of any two irrational numbers may or may not be irrational, because it may be rational, it may be irrational. It has to be one of the two. It has to be rational or irrational. It has to be one of the two. So may or may not be irrational. It may be irrational. It may not be irrational. Is the right answer. Next one. A rational number between root 3 and root 5 is option A. Does option A represent a rational number? Option A, does it? No, option A does not represent a rational number. What about option B?
It does not represent a rational number.
It doesn't represent a rational number. So we'll not consider these two options at all because we'll have to find a rational number between root 3 and root 5. So what's the value of root 3? .414 and root 5 is 2.234. And now 3 or 2. 3 does not lie between these two numbers. 3 does not lie between these two numbers. So the correct option is 2. 2 lies between these two numbers.
Mom,
2. Yes.
Mom, root 3 is 1.732.
Oh, sorry. Yeah. I'm so sorry. Root 3 is 1.732. I'm so sorry. Yeah. Root 3 is 1.732. Yes. So now between these two, 2 lies between these two numbers, not 3. So the correct option is D, right? The correct option is D. Option A, the expression in option A is irrational. The expression in option B is also irrational. We'll have to find a rational number between root 3 and root 5. Now, these two options represent rational numbers. So it has to be 3 or 2. So root 3 is 1.732. Root 5 is 2.234. Clearly, 2 lies between these two numbers. So the correct option is 2 or option D. Yeah. Rationalizing factor for the denominator of the expression 1 by root 7 minus 2 is?
Root 7 plus
Root
2.
7 plus 2.
Correct. Root 7 plus 2. Correct. Root 7 plus 2. Next one. Every irrational number is?
A
A real number.
A real number.
Yeah. Every irrational number is a real number. Is a real number. Yeah. Okay, so you must have read the case study. Let's answer the questions. Root 5 is an irrational number, an integer, a
Irrational
rational number, a whole number. Irrational
An
number.
irrational
Correct.
number.
Is an irrational number. Correct. Then 3 root 5 plus root 5 is equal to
4 root 5.
4
root 5. 4 root 5. Root 5. Yeah. The sum of a rational and an irrational number is rational and irrational.
Always an irrational number.
Always an irrational number.
Always.
Correct. Yeah, because there is one of the two numbers, one is irrational, one is rational, the other is irrational, like 2 plus root 3. So rational, an irrational number has a non-terminating, non-repeating decimal expansion. To that, if you add a rational number, that will be, the sum will be a new non-terminating, non-repeating decimal. One is rational, the other is irrational. So now this irrational has a non-terminating, non-repeating decimal expansion. So to that, if you add a rational number, the sum will be another non-terminating, non-repeating decimal. So it is always irrational. The sum of a rational and an irrational number is always irrational. Is always irrational. Right. Decimal representation of an irrational number is?
Non-terminating and non-repeating.
Non-terminating, non-repeating.
Non-terminating, non-repeating. Correct. Non-terminating, non-repeating. And what about the value of root of 25, the whole power minus 2?
1 by 25.
1 by 25. Okay. So that's nothing but For 25 is 5 squared. 25 is 5 squared. Then you have that power minus 2. And that square root symbol, which is the radical form, when you put it in the exponential form, it is to the power 1 by 2. So it's like this. 25 is 5 squared. Then we have this power minus 2 already. So that minus 2 here. And the square root symbol, this radical symbol, when you put it in the exponential form, it is to the power 1 by 2. So now you'll have to multiply the power. Or you can just cancel like this. Otherwise, if you want to write one more step, 5, multiply the powers. The base is 5, multiply all the powers. 2 into minus 2 into 1 by 2. So 2 gets cancelled. So it's 5 to the power minus 2. 5 to the power minus 2. So we recall from 8th standard in the last class, when you want to find the value of an expression with a negative power, when you have to find the value of an expression with a negative power, you'll have to make the negative power positive. So if you want, correct. So when you make the negative power positive, you should take the reciprocal of the base. Which means when you want to write the equivalent of this one, 5 to the power minus 2, you'll have to do two things. Take the reciprocal of the base. 5 by 1 should be written as 1 by 5. And write the negative of the power. Minus 2 becomes plus 2. So it's 1 by 25. The answer is 1 by 25. 1 by 25. Another way of doing the same question is square root of so 25 to the power minus 2, right? 25 to the power minus 2. So the power is negative. You want to make it positive. So take the reciprocal of the base. 25 is written as 1 by 25. And minus 2 becomes plus 2. 25 by 1 is written as 1 by 25. Reciprocal of the base. And the power minus 2 is written as plus 2. So these are equivalents. 25 to the power minus 2 is the same as 1 by 25 to the power 2. So now, like under the square root, you have 1 by 25 into 1 by 25 because 1 by 25 the whole square, right? So we have 1 by 25 into 1 by 25 under the square root. So from two equal expressions, one comes out, right? So 1 by 25 because under the square root, 1 by 25 into 1 by 25. So 1 by 25 comes out of the square root. So this is the answer. This is the value. You can also work it like this. Okay. Yeah. The decimal expansion of a rational number is?
Terminating or non-terminating repeating.
Correct. Terminating or non-terminating repeating. Terminating or non-terminating repeating. A rational number can have a terminating decimal expansion or a non-terminating repeating decimal expansion. Next one. Rationalizing factor of 1 by root a minus root b is?
Root a plus root b.
Yeah, others?
1 by root A plus root B, ma'am.
Okay. So whenever they ask you this question, this is the answer, because rationalizing factor of 1 by root A minus root B. So which part is irrational here? This one is irrational. So though the question is rationalizing factor of this expression, it's actually the rationalizing factor of the denominator, because the denominator is what is irrational. The denominator is irrational. So you have to rationalize that. So the question is, the rationalizing factor of this one is this one. The rationalizing factor of the denominator, root A minus root B, is root A plus root B. Option A. We saw a similar question here, no? Yeah. Rationalizing factor. Yeah. A rational number between 1 by 7 and 2 by 7 is?
5 by 21.
5 by 21.
5 by 20.
5
by 14, miss.
All right. So we have denominators 14, 27, 14 and 21. All right. So 1 by 7 into 2 by 2 is 2 by 14. And 2 by 7 into 2 by 2 is 4 by 14. So clearly 5 by 14 does not lie between 1 by 7 and 2 by 7, because 1 by 7 is also 2 by 14. 2 by 7 is also 4 by 14. But you see that 5 by 14 does not lie between these two. A rational number between 1 by 7 and 2 by 7. 1 by 7 is equal to 2 by 14. 2 by 7 is equal to 4 by 14. So clearly 5 by 14 does not lie between 1 by 7 and 2 by 7. So this is eliminated. 5 by 14 is eliminated. Similarly, 1 by 14. 1 by 7 into 2 by 2. 2 by 14. So clearly see that. So 2 by 7 into 2 by 2. 4 by 14. Now this is 1 by 14. So again, it doesn't lie between 1 by 14. Does not lie between 2 by 14 and 4 by 14. So this also is eliminated. Now 5 by 21. 5 by 21. So into 3. Multiply and divide by 3. 3 by 21 and 6 by 21. Yes. 5 by 21 lies between. And the question is a rational number. And we found it. So you don't have to check for this at all. A rational number between 1 by 7 and 2 by 7 is 5 by 21. This is the correct option. 5 by 21. Okay. On adding 2 root 3 and 3 root, on adding 2 root 3 and 3 root 2, we get
None of these.
5 into root 3 plus root 2.
2 root 3 plus 3
None
root
of these, ma'am.
Okay, who says none of these?
Sai Smriti, ma'am.
Okay, your answer is none of these. Okay. And Nuved, you say B, is it? 5 into root 3 plus root 2.
Yes, miss.
Okay, others?
Ma'am, none of
2 root
these.
3 plus 3 root 2.
Ma'am, 2 root 3 plus 3 root 2.
Yeah, even I go with that. On adding 2 root 3 and 3 root 2. See here, on adding 2 root 3 and 3 root 2, what do you get? You get the same thing. What do you get on adding x and y? On adding x and y, we get x plus y. That's all. This cannot be simplified further because they're not like terms. Similarly, 2 root 3 and 3 root 2, they are not like surds. They're unlike, no, because here the irrational factor is root 3 and here the irrational factor is root 2. So they're unlike. You can multiply them. You cannot add or subtract them. Even if you try to add or subtract them, you will get the same thing. Only that you will have to put the connecting sign. 2 root 3 and 3 root 2. When you add, you get 2 root 3 plus 3 root 2. This is itself. So this is the correct option. On adding 2 root 3 and 3 root 2, we get this one, option C. Option C is the correct option. Yeah, 16 to the power 3 by 4 is equal to
8.
8. Okay, 16 is 2. Okay, 16 is 2 raised to the power 4. 16 can be written as 2 raised to the power 4 into 3 by 4. So 2 cubed, which is 8. 2 cubed, which is 8. So the options are the first one, terminating or non-terminating repeating. Second one, root A plus root B. Third one, 5 by 21. 4, option C, and 5, option C. All children. So over to today's class work. Yeah. So simplify square root of x, the whole power minus 2 by 3 into square root of y to the power 4 divided by square root of x into y raised to the power minus 1 by 2. This power minus 1 by 2 is only for y, not for x. This power minus 1 by 2 is only for y, not for x. Because it is not xy, the whole raised to the power 1 by minus 1 by 2. It is not this. It is x into y raised to the power minus 1 by 2. So this power is only for y, not for x. If it is for x also, then the bracket should have been used. Okay. So now, as always, we will convert the radical signs to their equivalent exponential signs or exponential forms. So you can see here square root of x. So square root of x is nothing but x to the power 1 by 2. X to the power 1 by 2. And then this power minus 2 by 3. You can see here minus 2 by 3. Y to the power 4. You can see here y to the power 4. And the square root symbol converts to the power 1 by 2. 1 by 2 divided by xy to the power minus 1 by 2. You can see that here. And this radical sign square root becomes the whole power 1 by 2. Here, this radical sign square root is for this whole thing. So it will be the whole power minus the whole power 1 by 2. This power minus 1 by 2 is only for y. Minus 1 by 2 is for y. The square root symbol is for both of these. So you can see here the whole power 1 by 2. That's the first step. Now you can cancel wherever possible. So you can see the 2 here in the denominator and 2 here in the numerator gets cancelled. And here, this 4 means 4 by 1. 4 is 4 by 1. So 4 is in the numerator. 4 is in the numerator. This 2 is in the denominator. So you can cancel. So 2 ones are, 2 twos are. And here, you cannot cancel. See, now you cannot cancel 2 and 2 because both the 2's are in the denominator. Even if it was like this, you know, you cannot cancel this 2 and this 2. Because this power 2 is for x as well as y. This power 2, supposing it were 2, the power 2 is for both x and y. So you can, but this power minus 1 by 2 is only for y. This power minus 1 by 2 is only for y. Whereas this 2 is for both x and y. So if it were like this, x y to the power minus 1 by 2, the whole square, you cannot cancel this 2 and 2. Okay, so the next step, we have x to the power 1 by 3. See here, 1 into 1, because this is cancelled, no? 1 into 1, 1, minus, so minus 1 by 3. Minus 1 by 3 when you multiply the powers. When you multiply the powers, you get minus 1 by 3. And here after cancelling, we have a 2 here. So 2 into 1, 2, y square. See here, you have a 2 here. So 2 into 1, 2, y square. Divided by this power 1 by 2. It's for both x and y. So x to the power 1 by 2. And this y already has a power minus 1 by 2. And another power 1 by 2. So into 1 by 2. So it will be y to the power minus 1 by 4. Y to the power minus 1 by 4. This power 1 by 2 for x. X to the power 1 by 2. This power 1 by 2 for y. But y is already raised to the power minus 1 by 2. So you'll have to multiply the powers. Y to the power minus 1 by 2 into 1 by 2. Y already has a power and now another power 1 by 2. So multiply the powers. So that way you get minus 1 by 4. So that's the next step. That's the next step. Now, so this is nothing but you can see, you can understand this just to understand the situation. I've just presented it like this. So it is, you can see this here, you can see this here, divided by, no, divided by. So I've used this division symbol. You can see the x term here and the y term here. Divided by, no. You can see these two terms in the numerator as it is. Divided by. So divided by these two terms in the denominator as they are. I just converted this division symbol to this by sign. Numerator by denominator. Now use the law of exponents. When bases are same and it's division, we subtract the powers. So x, base are same and it's division. So we subtract the powers. Minus 1 by 3, minus 1 by 2. Here also subtract the powers. So it'll be y to the power 2 minus 1 by 4. You should subtract the powers. What are the powers? 2 and minus 1 by 4 are the powers. The powers are 2 and minus 1 by 4. You should subtract the powers. So it'll be y to the power 2 plus 1 by 4. I repeat. Bases are same and it's division. So we need to subtract the powers. Y to the power 2 in the numerator and y to the power minus 1 by 4 in the denominator. You'll have to subtract the powers. Okay, so this is the power in the numerator. This is the power in the denominator. Subtract the powers. So minus into minus plus 2 plus 1 by 4. That's what you see here. Now after this, you will have to take up the common denominator and simplify further. Simplify the powers further. Okay, take up the common denominator here and here and simplify. where you'll get x to the power minus 5 by 6, x to the y to the power 9 by 4. X to the power minus 5 by 6 into y to the power 9 by 4. So if the power is, negative, you can make it positive by simply changing the position of that term. Now, for example, if you have 2 to the power minus 3, or say x to the power minus 2 by y to the power minus 3. Okay, so if you want to make these negative powers positive, simply change their positions. So if x to the power minus 2 comes to the denominator, it will become x to the power 2. And if y to the power minus 3 goes to the numerator, it will become y to the power 3. Just change their positions. Because when you change their positions, you're taking the reciprocal of the base. When you change their positions, you're taking the reciprocal of the base. So you just have to write the negative of the power, which are equals. Which are equals. How do you write the equivalent of? Yeah. What's the equivalent of x to the power minus 3? We'll have to take the reciprocal of the base. So x is x by 1. So its reciprocal is 1 by x. And minus 3 is plus 3. Reciprocal of the base, negative of the power. Now these two are equal. Okay. So when you have x to the power minus 3 by y to the power minus 2, you want to make the negative powers positive. Just change their positions, meaning if it's in the denominator, take it to the numerator. If it's in the numerator, bring it to the denominator. The negative powers will become positive. So when you write y to the power minus 2 in the numerator, it becomes plus 2. And x to the power minus 3, when it comes to the denominator, it will become x to the power 3. Same rule. When you change the position, you're writing the reciprocal of the base. So just write the negative of the power. That's what you see here. X to the power minus 5 by 6. X to the power minus 5 by 6. It's in the numerator. So write it in the denominator. Then minus 5 by 6 will become plus 5 by 6. And this one is already with the positive power and it's in the numerator. So write it in the numerator. This one, write it in the numerator. And this, since the power is negative and you want to write it with a positive power, write this in the denominator. When you do that, the negative power becomes positive. So that's the answer. Write down. Please write down, children.
Finished, ma'am.
Very good. Done writing, all of you?
2 minutes.
Yeah, done writing, children?
Yes, miss.
Yes, ma'am.
All right, good. Okay. This is the next one. So square root, sorry, fifth root of x to the power 4 into fourth root of x cubed into cube root of x square, and we'll write this as x to the power what? X to the power
1/2.
1/2. Okay, so we start simplifying from the innermost radical sign. So innermost we have square root of x. So we'll write that as x to the power 1/2. Others we've written as they are. Others we've written as they look. The only change we've done here is we've written square root of x as x to the power 1/2. That's all. Rest we've written as it is. Now again, fifth root of x to the power 4 into fourth root of x cubed into cube root of, now we have x square into x to the power 1/2. So base are same and it's multiplication. So we need to add the powers. When you add the powers, 2 plus 1/2, you get 5/2. So we have x to the power 5/2 here. Okay. Base are same, multiplication, add the powers. 2 plus 1/2 is 5/2. Now next step, fifth root of x to the power 4 into fourth root of x cubed into x to the power 5/2. Well, how do you write cube root of x to the power 5/2 in the exponential form?
X power 5/2 into 1/3.
Correct. Very good. See, we are talking about this part, this one. This expression, how do we put it in the exponential form? Cube root of x to the power 5/2. So that's nothing but x to the power 5/2 into 1/3. Or x to the power 5/2, the whole power 1/3. Both are the same. X to the power 5/2 in the power x to the power 5/2 into 1/3 like this. Or you can write it as x to the power 5/2, the whole power 1/3. Both are the same because when the base is raised to many powers, we have to multiply the powers. So we have x to the power 5/2 into 1/3. So the next step, what will happen? 5/2 into 1/3. What is that? 5 into 1, 5, 2 into 3, 6. So 5/6. Yes or no? It will become x to the power 5/6. Yeah. 5/6. Because it is x to the power 5/2 into 1/3. So next step, 5 into 1, 5, 2 into 3, 6. So x to the power 5/6. Now, here base are same and it's multiplication. So we need to add the powers. So it'll be 3 plus 5 by 6. 3 plus 5 by 6. Add the powers. 3 plus 5 by 6. 6 3s are 18. 18 plus 5, 23. 23 by 6. So next step, fifth root of x to the power 4 into fourth root of, when we multiply, we use the law of exponents as we just discussed. Base are same, multiplication, add the powers. On adding, you get x to the power, what did I say? 18, 23 by 6. 23 by 6. Now next step, fifth root of x to the power 4 into, there is no sign here, that means multiplication. No sign means multiplication. Everywhere it's multiplication. So x to the power 23 by 6 into 1 by 4. Into 1 by 4. Because fourth root. Under the fourth root, what do you have? X to the power 23 by 6. So x to the power 23 by 6. And fourth root means to the power 1 by 4 or into 1 by 4. So we have fifth root of x to the power 4 into x to the power. So 23 into 1 is 23. 6 4s are 24. So you get 23 by 24. 23 by 24. Now again, bases are same. And it's multiplication. So we need to add the powers. We need to add the powers. 4 plus 23 by 4. 4 plus 23 by, 24. 4 plus 23 by 24. So 24 is a common denominator. 20, here it's 1. So 4 into 24, 16, 1 carried over, 96 plus 23. So it will be 119 by 24. 119 by 24. So next step we have fifth root of. So we apply the law of exponents here, right? Base are same and it's multiplication. So we have to add the powers. The powers are 4 and 23 by 4. Add the powers. So 4 plus 23 by 4. On taking the LCM and simplifying, we get 119 by 24. So x to the power 119 by 24. Next step, x to the power 119 by 24. Fifth root, meaning into 1 by 5. So multiply. X to the power 119 into 1 is 119 by 24 into 5 is 120. So this is the answer. X to the power 119 by 120. Yeah, please write down. Please don't copy blindly. Understand every step. Every time you write, understand that step and then go to the next one. See, when you write this, understand what's written here. Then go to this one. Understand this and then this. Do it like that. Don't blindly copy. You will need at least about 8 minutes for this. I'll just come back. Please work.
Least, ma'am.
Finish writing, children.
Yes, miss.
Yes, ma'am.
Okay. We'll just try
Yes,
this
ma'am.
once again. Yeah, good. We'll just work this once again. Yeah. So now this time you're going to prompt. Tell me. Fifth root of x to the power 4. You can take a multiplication sign if you want to understand better. So x to the power 4 into fourth root of x to the power 3 into cube root of x to the power 2 into. Now we'll have to write square root of x as
X power 1 by 2.
x to the power 1 by 2. X to the power 1 by 2. So next step, all as it is, fifth root of x to the power 4 into fourth root of x cubed into, so cube root of x to the power 2 plus 1 by 2, right? Base are same, multiplication, so we'll have to add the powers. 2 plus 1 by 2 is 5 by 2. So x to the power 5 by 2, right? My God, what have I written? Sorry. Fourth root of x cube into, yeah, here we are, cube root of x to the power 5 by 2, correct? Next step. Yeah, tell me. Fifth root of, yeah,
X power 4 into fourth root of x power 3 into x power 5 by 2 into 1 by 3.
very good. 5 by 2 into 1 by 3. So in the next step, it would become This one would become, next step, this one,
5 by 6.
5 by
X
6. So
power
I'll
5
just
by
write
6.
it.
5 by 6,
Yeah.
ma'am.
Yeah, I'll just write that here itself, 5 by 6. 5 by 6. Now again, yeah, please tell me. Fifth root of,
We should add 3 plus 5 by 6.
fifth root of x to the power 4 into fourth root of, add the powers. Base are same, multiplication, add the power. So 3 plus 5 by 6. 3 plus 5 by 6, 23 by 6. So x to the power 23 by 6. Again, fifth root of x to the power 4 into, yeah, tell me.
X to the power 23 by 6 into 1 by 4.
Into 1 by 4, into 1 by 4. So next step, fifth root of x to the power 4 into x to the power 23 by 24. Now again the bases are same, multiplication, add the powers. 4 plus 23 by 4, right? So what do you get? Oh, not 4, so 24, sorry. X to the power 4 into fifth root of x to the power 4 into x to the power 23 by 24. Fifth root of x to the power 4 into x to the power 23 by 24. I said 4 by mistake. 6 4s are 24, so 23 by 24. So 4 plus 23 by 24.
119 by 24.
Correct. 119 by 24. So fifth root of x to the power 119 by 24. Next step.
X power 119 by 24 into 1 by 5.
Into 1 by 5. Correct. So that is x to the power 119 by 120. Very nice. Yeah. You can work this by yourself. Relatively easier. Please try.
Finish working, mom.
Yeah. So x to the power minus 1 is equal to x means x by 1. The base x means x by 1. Reciprocal of the base 1 by x. Negative of the power minus 1 becomes plus 1. So x to the power minus 1 is the same as 1 by x to the power 1, which is nothing but 1 by x. Which is nothing but 1 by x. Reciprocal of the base, negative of the power. Similarly, y to the power minus 1 is the same as y means y by 1. So its reciprocal is 1 by y. Minus 1, its negative is plus 1. So y to the power minus 1 is the same as 1 by y to the power 1, which is nothing but 1 by y. Okay, so here we have square root of x to the power minus 1 is nothing but 1 by x into y. See, there is no sign, so it's into here. See, when we write AB, it means it's A into B. So 1 by x into y. Here 1 by y into z. Here 1 by z into x. So 1 by x into y. What is 1 by x into y? It's y by x. Y by x. It's y by x. So it's y by x, z by y, and x by z. So square root of a into square root of b into square root of c is equal to square root of a into b into c. The square root of y by x into z by y into x by z. Y, z, z, sorry, z and z, x and x. It's cancelled. So it's square root of 1, which is 1. Square root of 1, which is 1. Okay. Yeah. Yeah, you can try this also yourself. So here we make use of the identity a minus b into a plus b is a squared minus b squared. Yeah, please work this. Completed, children?
Yes, ma'am.
Yes.
Okay,
Yes, ma'am.
correct. So first, we use this law of exponent, which says when bases are same and its division, subtract the powers. Bases are same and its division, subtract the powers. So x, base are same, it's division. So we'll have to subtract the powers, a minus b. So x to the power a minus b. This one becomes x to the power a minus b. And then there's already this power a plus b. So write that as it is. Into. Same rule here. X to the power b divided by x to the power c. Bases are same, division, subtract the powers. X to the power b minus c. And there's already this power b plus c. Similarly, x to the power c minus a and this power c plus a. That will be the first step. Now, again, another law of exponents which says a to the power m, the whole power n is equal to a to the power mn. So you have a base raised to more than one power. Multiply the powers. Write the same base and multiply the powers. So here the base is x. Write that and multiply the powers. A minus b into a plus b. So similarly, b minus c into b plus c. X to the power c minus a into c plus a. That's the next step. Now a minus b into a plus b is a squared minus b squared. So x to the power a squared minus b squared. Again, x to the power b minus c into b plus c is b squared minus c squared. X to the power c minus a into c plus a is c squared minus a squared. That's the next step. Now again, bases are same. And it's multiplication. Add the powers. Add the power. So x to the power, the base is x. The base is x, write that. And add the powers. So a square minus b square plus b square minus c square plus c square minus a square. So you see a square minus a square minus a square minus b square plus b square minus c square plus c square. 0. X to the power 0, which is 1. Anything raised to the power 0 is 1. All right. All of you finished writing? Any questions here?
No, ma'am.
Very good. Yeah, work this. Completed, children?
2 minutes, ma'am.
Okay.
Completed, miss.
Finished?
Yes, miss.
Okay.
1 minute.
Completed, ma'am.
Yeah. Okay, so you can see this radical sign, LMth root of, okay? So that radical sign LMth root of becomes to the power 1 by LM. 1 by LM. If it's 4, it becomes 1 by 4. In the same way, if it's LM, it becomes 1 by LM in the exponential form. So LMth root of x to the power L divided by x to the power M. So in the exponential form, this is written as x to the power L by x to the power M, the whole raised to the power 1 by LM, 1 by LM. Similarly here, x to the power M by x to the power N, the whole power 1 by Mn, mnth root of, this is mnth root of x to the power M by x to the power N. And this one, it's the nth root, nth root of x to the power n by x to the power L. So you can see here x to the power n by x to the power L, and this nth root in the exponential form is 1 by NL to the power 1 by NL. So that's the first step. And here base are same, it's division, subtract the powers. So L minus M, x to the power M minus N, x to the power N minus L, and write the respective powers. Okay. That's about this step. And then we know when the base is raised to more than one power, we'll have to multiply the powers. So we have power L minus M, and we have another power 1 by Ln. So multiply the powers. When you multiply the powers, it is L minus M into 1 by Ln. So L minus M into 1 is L minus M by Ln. So that's what you see here, L minus M by Ln. When you multiply these two powers, it's M minus N into 1 by Mn. So M minus N into 1 is M minus N by Mn. Similarly here, N minus L into 1. Okay, I think children, are you able to make out the difference between 1 and L in this print, children? This I told you, it's 1. We know this. This is reciprocal. These are 1s. In all other places, it is L. In all other places, it's L. See, only in this power here, 1 by Lm, 1 by Mn, 1 by NL. Only these three places we have 1. Only these three places we have 1. In all other places, it is L. Okay, so N minus L into 1 by NL. N minus L into 1 by NL. So when you multiply N minus L by NL. N minus L by NL. These three are 1s, children. These three are 1s. In all other places, whatever looks like 1 is not 1, it's L. See, in the question, we have 1 nowhere. In the question, we have 1 nowhere. Everywhere it is L. L. Everywhere it is L. everywhere it's L. Okay, so now bases are same and it's multiplication, so we need to add the powers. Bases are same, x, and it's multiplication, so we'll have to add the powers. So it is L minus M by Lm plus M minus N by Mn plus N minus L by Nl. So the common denominator is we have L, M, and N, these three letters. So L, M, N is the common denominator. So here we have L, M, we have L and M, we don't have N. So we'll have to multiply this one with, you'll have to multiply the numerator with N. So it'll be N into L minus M. Then this connecting sign plus. In the second one, the denominator is Mn. Mn is the denominator. So you need to multiply the numerator by L. So it'll be L into M minus N. And the last one, the denominator is NL. The denominator is NL. NL. So we need to multiply the numerator by M. So it'll be M into N minus L. So that's what you have here. Now we'll have to open up the brackets. N into L, NL or LN, whatever, both are the same. NL or LN, both are the same. Then N into M, NM or MN. I think I've written in the alphabetical order. That's why I've changed the order. LN, MN. No, what's the order, children? What comes first? LMN, right? Yeah. So I think I've written it in that order. LN. Well, when you multiply N and L, you can write NL or LN. You know, both are the same. So multiply these two, we get Ln. When you multiply these two, we get Mn minus Mn plus Lm or Ml minus Ln or Nl plus Mn minus Lm. So multiply, open the brackets. And then you can see plus Ln minus Ln or Nl. What's this? Minus Nm plus Nm minus Lm plus Ml or Lm gets cancelled. So we have x to the power 0 by, because when everything gets cancelled, the value is 0. So we have 0 by Lmn. So 0 by Lmn is nothing but 0. And x to the power 0 is 1. X to the power 0 is 1. Any part of the answer, if I'm not clear, please ask me. Any questions, children?
No, ma'am. No, ma'am.
All right. Okay. Yeah, this one is also similar. Why don't you leave some space for this, children? This is a similar one. You can just complete this later. I'll share the image with you on WhatsApp. Just write the question alone and leave some space. Complete it later. Yeah, write on the question, all of you. So there's no sign, it's multiplication. All right, next one. Okay, let's just try this one, children. Let's solve this equation and find the value of x. Do this one first. This is the first subdivision. Yeah, so here we have 3 to the power 5x into, right, 81 in base 3. What is 81 in base 3? 3 to the power? Quick. 3 to the power 4. And there's already that power 2, no? Correct. 81 is 3 to the power 4, but there's already the power 2. So 4 into 2, 8. So 3 to the power 8 into, what about 6561? Find out. 6561. Work and tell me.
What, miss?
Find the factors, find the prime factors of 6561.
3 to the power 8.
3 to the power 8. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 3 to the power 8. Divided
3
by,
to the power 8, miss.
yeah, correct. 3 to the power 2x is equal to 3 to the power 7. Now, the base is 3 everywhere. So how do you simplify the left-hand side? 3 to the power 5x plus 8 minus 2x. Because when base are same and it's multiplication, we add the powers. Division, we subtract the powers. So we'll have 3 to the power 5x plus 8 minus 2x is equal to 3 to the power 7. So 3 to the power 5x minus 2x is 3x. 8 plus 8 is 16. Is equal to 3 to the power 7. Now when bases are same on both the sides, bases are same on both the sides, you can equate the powers. So we have 3x plus 16 is equal to 7. When bases are same on both the sides, you can equate the powers. Like 3 and 3, bases are same on both the sides. So equate the powers. 3x plus 16 is equal to 7. 3x is equal to 7 minus 16. 3x is equal to minus 9. X is equal to minus 9 by 3. X is equal to minus 3. Right on? Please work, children.
Finished, ma'am.
Done.
Finish writing, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very nice. All right. Next.
Yes.
All right, children. So here, the one which we just finished, find x if an equation was given to you. Similar question. An equation is given 4 to the power 2x minus 1 minus 16 to the power x minus 1 is equal to 384. We need to solve this equation and find the value of x. Okay. So 4 to the power 2x minus 1 minus, what is 16 in base 4? What is 16 in base 4?
Four square.
4 squared. Okay, so 16 is 4 to the power 2. But there's already this power x minus 1, right? So you'll have to multiply the powers. 16 is 4 to the power 2. But 16 is already raised to the power x minus 1. So multiply the powers x minus 1. 4 to the power 2 into x minus 1 is equal to, for now, you don't have to do anything with 384 because we're going to simplify only the LHS first. So you can just write 384 as it is. For now, we're not going to do anything with this. Even if you want to do something, you can only find the prime factors and write it as a product of its prime factors. That's all you can do. You can do it if you want. But now I'm saying that we are going to simplify the left-hand side. So we'll not do anything with 384 now. So on the left-hand side, we have 4 to the power 2x minus 1 minus 4 to the power, open the bracket, so 2x minus 2 is equal to 384. Now, When there's a plus or a minus sign in the middle, see, you cannot say bases are same and it's subtraction, so subtract the powers. No. When bases are same and it's division, you subtract the powers. When bases are same and it's multiplication, you add the powers. But when bases are same and it's subtraction, you cannot use one of these two laws. So what do? You'll have to take out common. Okay, you'll have to take out common. So how do you take out common? So the two terms are 4 to the power 2x minus 1 and 4 to the power 2x minus 2. See, actually, you can take out any one of these two common. You can take out any one of these two common. Now, supposing I take out 4 to the power 2x minus 2 common. You can even take 4 to the power 2x minus 1 as common. Okay, so now I take 4 to the power 2x minus 2 as common. So 4 to the power 2x minus 2. 4 to the power 2x minus 2 into 4 to the power what will give you this first term 4 to the power 2x minus 1. See, you have taken out 4 to the power 2x minus 2 common. So this one into what? Into what will give us the first term 4 to the power 2x minus 1. So here we have 2x, right? So we have 2x here. Okay. Now this minus 2 should become minus 1. Minus 2 should become minus 1. So that means you should take up 1 here. Because in that case, it will be 4 to the power 2x minus 2. Bases are same, it's multiplication. So you'll add the powers. And minus 2 plus 1 will give us 2x minus 1. I'll repeat this. See, I've taken out 4 to the power 2x minus 2 common. Now 4 to the power 2x minus 2 into 4 to the power what will give you 4 to the power 2x minus 1, the first term, 4 to the power 2x minus 1. So 4 to the power 2x minus 2 into 4 to the power 1 will give you 4 to the power 2x minus 1. Because when bases are same and it's multiplication, we add the powers. When you add the powers, you get 4 to the power 2x minus 2 plus 1. And what is minus 2 plus 1? Minus 1. So 4 to the power 2x minus 1. Minus the sign minus 4 to the power. So this one 4 to the power 2x minus 2 in this minus sign I told you, put it as it is. Now 4 to the power 2x minus 2, which is common, that sorry. Yeah. Yeah. 4 to the power 2x minus 2 into 4 to the power what will give you the same term. 4 to the power 0. 4 to the power 2x minus 2 into 4 to the power 0. See, you'll have to multiply these two. Into 4 to the power 0 will give you the same thing, right? 2x minus 2. This one into what will give you the same thing? Same thing means 4 to the power 0. Because when you add the powers, 2x minus 2 plus 0 is 2x minus 2. Is equal to 384. Right here it is 1. Yeah, so we have 4 to the power 2x minus 2 into 4 to the power 1, which is 4, minus 4 to the power 0, which is 1, is equal to 384. So 4 to the power 2x minus 2, 4 minus 1 is 3, into 3 is equal to 384. 4 to the power 2x minus 2 is equal to 384 divided by 3 into 3. On the other side, divided by 3. So 4 to the power 2x minus 2 is equal to 128. Now 128 cannot be written in base 4, but you can write it in base 2. 128 is 2 to the power 7. 128 is 2 to the power 7. You cannot write it in base 4 because 4 squared is 16, 4 cubed is 64, and 4 to the power 4 is 256. So 128 cannot be written in base 4. I'm saying with a natural number as the power or with a whole number power, like 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. 4 raised to no whole number can give you 128. But 2 to the power 7 is 128. So on the other side, that is on the left-hand side, write 4 as 2 squared. And then there's already the power 2x minus 2, so multiply the powers. So it'll be like this. Left-hand side, we have 4. So we write that as 2 squared. And this power, which is already there, 2x minus 2. So multiply the powers into 2x minus 2 is equal to 128 is 2 to the power 7. So 2 to the power, open the bracket. So 4x minus 4 is equal to 2 to the power 7. Now bases are same on both the sides. So equate the powers. 4x minus 4 is equal to 7. 4x is equal to 7 plus 4, 11. X is equal to 11 by 4. So the value of x is 11 by 4. Yeah, please write, children. Yeah, please work.
Finished, ma'am. Finished, ma'am.
All right.
Yes, ma'am.
Okay. So here, when I explained, I did mention that you can take out 4 to the power 2x minus 1 or 4 to the power 2x minus 2. One of the two you can take out as common. So when I explained here, I explained with 4 to the power 2x minus 2. In the working here, you can see I've taken out 4 to the power 2x minus 1 as common. So this into this will give you the first term. And this into this will give you the second term. This into this will give us the first term. This into this will give us the second term. 4 to the power 2x minus 1 into 4 to the power 0. Base are same, it's multiplication. When you add the powers, you will get the same thing. 4 to the power 2x minus 1 plus 0, which is 4 to the power 2x minus 1. That's the first term. And then when you multiply 4 to the power 2x minus 1 with the second term, 4 to the power minus 1, add the powers. 4 to the power 2x minus 1 is minus 2, which is the second term here. So when you take out 4 to the power 2x minus 1 is common. This into this will give you the first term minus this into this will give you the second term is equal to 384. So this one as it is, 4 to the power 0 is 1 and 4 to the power minus 1 is 1 by 4. Reciprocal of the base 1 by 4 and negative of the power minus 1 becomes plus 1. So you don't have to write the power is equal to 384. So 4 to the power 2x minus 1 into 1 minus 1 by 4 on taking the LCM, it's 3 by 4 or otherwise also, 1 minus 1 by 4 is 3 by 4 is equal to 384. 3 by 4 on the other side becomes 4 by 3. When you transpose, it becomes 4 by 3. Now 3 ones are and 3 128 times. Cancel. 3 ones are 3 128 times. Cancel them. Then we have 128, which is 2 to the power 7. We have 4, which is 2 squared. We have 128, which is 2 to the power 7. And we have 4, which is 2 squared. So here also you write this one in base 2. So 4 is 2 squared and this power 2x minus 1. So multiply the powers. You get 4x minus 2. 4x minus 2 is equal to 2 to the power 9 because 7 plus 2 is 9. Now we equate the powers. 4x minus 2 is equal to 9. 4x is equal to 9 plus 2, 11. X is equal to 11 by 4. Got it, children?
Yes, ma'am.
Any questions? Please ask me.
No, ma'am.
Okay, class, use the emoji. Raise your hand. Aishwarya, Haridarshan, Surya, Naved, Sai Sudesh, Harsha, Yarni, Lakshana, and Netra. All right.